Okay, then today our discussion is about multiple regression analysis. In previous sessions, we had a discussion about simple linear regression model. In the simple linear regression model, we have only one independent variable. We assume y is a function of x1, or we can say earnings is a function of schooling. There are only one independent variables. Then our regression model is y equal beta 1 plus beta 2, let's say x plus error term. This is simple linear regression model. Now we have assumed earning is a function of schooling. But we know practically our earnings may depend on many other factors. It is not only depend our schooling, there are many other factors. What are the other factors which determine our earnings? Any answer? Now in simple model, we have assumed our earnings is depend only our level of education. Do you think that it is only depend on our education? What are the other factors?
Experience,
Yes, we can say earning is a function of schooling as well as experience. What else?
working hours,
Working hours. Okay, that also we can consider working hours. Yes, what else? Working hours. Maybe your gender, no? Maybe working sector, whether you are working in private sector or public sector. These are the some independent variable which determine your earnings. Then now you have to extend your simple model. Y is equal now beta 1 plus beta 2 x 1 plus beta 3 x2. You can extend your model up to any number of independent variable. It is we call multiple regression model. In a simple model, you have only one independent variable, but multiple model, there is no limit. You can include any number of independent variables. Then in this session, we are going to learn how to estimate multiple regression model and how to interpret the results of multiple regression model. I think now you may have idea about what is the multiple regression model. It is a regression model with more than one independent variable. To estimate multiple regression model, you can use OLS method as we use for simple model. Now base is same as simple linear regression model. Now here you can see this is y, this is we call true model. Then y hat is the pitted model. Y hat is the pitted model. Then the difference between y, that means true value, and the y hat is we call error term. Now in the OLS method, the rationale is we derive equation for beta 1, beta 2, beta 3 with minimum errors. With minimum errors. Then to derive equation for beta 1, beta 2, beta 3 with minimum errors, what we can do is we can get the square of this residual square. Then we know we have a residual for each and every observation. Then we get the summation of residuals. We get the summation of residuals. We get the square of this, that means square of this one, and get the summation of this. It is we call residual sum of square. It is similar to the concept we learn for simple model. Then the next step is we get the derivative of this equation. That means we expand this one, then we have this type of equation. Then we get the derivative of this equation with respect to B1, B2 and B3. Then we can derive equation for beta 1 and beta 2. Okay. Then the beta 1 is equal y bar, beta 2 x bar 2, beta 3 x bar 3. Okay. And then the beta 2 is equal this equation. Here you can see x2 I minus x bar, yi minus y bar, x3 I minus x3 bar. Like this we have a equation. Then if you are doing manual calculation, you have to use this equation to calculate value for beta 2. Then just I explain this, no need to memorize this equation, but you should know how that mean the concept. That mean concept mean here for the multiple regression model also we use OLS method. The rationale is we derive equation for beta 1, beta 2 and 3 with minimum errors. That concept you should have idea about that concept, but no need to memorize or no need to derive this equation. Okay. Then the how to get the uh, equation for beta 3. Now beta 2 is this equation, then beta 3. Then all these two values you will have to change into 3. Uh, two values we change into 3. Yes. Then this is x3, this is also x3. Then this is x2, this is x2. Then this become x2, this become x3. Then you have an equation for beta 3. Okay. Then you can derive value for beta 1 and beta 2 and beta 3. Is it clear up to this point? Okay. Now this shows regression results with the startup. This shows the regression results with the startup. Rig is the command. Then we have independent variable earnings. Sorry, dependent variable earnings, schooling and experience. Now you should know how to derive regression equation from here. This is we call regression output. Once you get this regression output, first you should know how to derive this regression equation. It is very simple. You can see here earnings. Earnings mean our dependent variable. Then it's come here. Then independent variables are schooling, experience, and constant. Then there are coefficients. There. That means this is the beta 1, this is the beta 2, this is the beta 3. Then the equation is this. Okay. It's very simple technical part. The dependent variable is here, independents are here, constant is here, then you can write the equation. This is the first thing you have to do. Then the second thing is you have to interpret these values. You have to interpret these values. It is similar to the interpretation of simple linear regression model. Let's say when you interpret beta 2 and beta 3, what are the things you have to consider? To give a clear interpretation, you should know unit of measurement. Unit of measurement. Unit of measurement of dependent variable and independent variable. Now in this example, our dependent variable, we measure earnings, hourly earnings. Okay. Hourly earnings in dollar. Hourly earnings in dollar per hour. Earnings for earnings in dollar. Then the schooling we measure in years. How many years of schooling? Experience also we measure in years. In the first part of interpretation, you can interpret this sign. Now, sign of the schooling coefficient beta 2 is plus. What does it indicate? Sign. It indicates the earnings and schooling. Then the first statement related to interpretation of beta 2 is as the sign of beta 2 is positive, there is a positive relationship between earnings and schoolings. When schooling increase, earning also increase. That is the first point. The second point is you can say about this value. How to interpret this value? Then this shows that when schooling change mean it may be increase or decrease, change by 1 year, change by 1 year. Hourly earnings change by $1.88. That is the second point. When schooling change by 1 year, hourly earnings change by $1.88. Okay. Then further you can explain this. You can say when schooling increase by 1 year, earnings will increase by $1.88. That is the interpretation for schooling. Is it clear? If I explain again, first you will have to tell about the sign of the coefficient. It is plus. Then you can say there is a positive relationship between schooling and earnings. Then the value. About the value, you can say two things. Once you can say when schooling change by 1 year, earnings will change by $1.88. Further, you can explain it when schooling increase by extra year or additional year. Earnings will increase by $1.88. Okay. That is the interpretation for schooling. Then now you can interpret this value. Okay. 0.98. It is experience, also measures in years. Okay, then I explain the first one. Then now you can send the interpretation for the beta 3 to chat box. Please type or write in a paper. You can upload the answer or you can send your answer into chat box. I'll give 5 minutes. Then I need answer from all of you. There are 20 students. Then actively attend this. Please send your interpretation for beta 3. It is very simple. I know you can do, but please do it. Okay, I will give 5 minutes. Yes, I have received nearly, I think, 10 answers. All are correct. I think now you know how to interpret the regression coefficient. Then, how about the interpretation for constant? Interpretation for constant. Constant means this very. Then you can see there are interpretation. It indicates that our earnings increased by 1.88 per extra for every extra year of schooling, and by $0.98 for every extra year of work experience. Then the intercept indicate that an individual who had no schooling or work experience. That means schooling is zero as well as experience is zero. If both the schooling and experience are zero, then the earning is this much. That is the theoretical interpretation.
It's a minus number. What does that mean?
Yes, actually now there is no meaning of this because it is actually impossible number. No, in, in, in the earnings we can't say it is minus. That means it may be something like this. This may happen due to the problem in our model or data set. Now, one thing is that in our model, we have schooling only 8 years. That the minimum schooling is in our model 8 years. Then we have, but in the estimation, uh, it shows intercept uh, earnings for zero level of education. Then if you had a uh, real data for zero level of education and earnings, then you may have a different value for this. That is the one reason. The second reason is here we have assumed the model is a linear model like this. Sometimes the actual situation may be non-linear. Okay. These are the two reasons that we have uh, unrealistic value for beta 1. Okay, this is the interpretation for uh, regression coefficient. Then next one is then you have to interpret the significance of these regression coefficients. Once you give the interpretation, you have to say whether these coefficients beta 1, beta 2 and beta 3 are significantly different from zero. How you say that whether beta 1 is significantly different from 0. It is based on hypothesis testing. We learn for simple linear regression model. Now here you can see t value. T value. This t value is equal the coefficient beta 1 divided by standard error of beta 1. That means this value divided by this. Then this is the t value. Then any regression output they are giving p value. As you know what is the p value? P value is the minimum level of significance which you can reject your null hypothesis. Now in this case p value is 0.00. Then when you are doing hypothesis testing, you can decide level of significance. Normally, accepted level of significance is 5%. Then you can compare this p-value with the level of significance. If p-value is less than to the level of significance, your conclusion is value of beta 1 is significantly different from 0. Okay. Beta 1 is significantly different from 0, which means beta 1 is a significant determinant of earnings. That means in the hypothesis concept, we can say beta 1 equals 0 and beta 1 not equal 0. As p-value is less than to the level of significance, then we can say we reject null. That means beta 1 is significantly different from 0. That means schooling is a significant determinant of earnings. Did you get the point? Now, significance of beta 1. Okay, this is the way to you have to explain it. As p-value of beta 1 is less than the level of significance, beta 1 is significantly different from 0, which means schooling is a significant determinant of earnings. In the same method, you can apply for experience. As p-value related to beta 3 is less than level of significance. Beta 3 is significantly different from 0, which means that experience is a significant determinant of earnings. Okay. Then this value also, it is not a realistic value, but at 5% level of significance, it also significant. This is the way to explain whether the coefficients are significant or not. Is it clear? Okay, then the next part is Next part is confidence interval. Now here you can see information related to confidence interval. Then how to interpret these values? Now confidence interval related to beta 2 is this one. Then this indicate that value of beta 2 is greater than 1.43 and less than 2.13 at 95% confidence level. That is the interpretation for confidence level. You can say, I am 95% confidence. True value of beta 2. True value of beta 2. True value of beta 2 is between 1.4 and 2.31 at 95% confidence level. And that means now this value is actually from sample. This value is from sample. Now confidence interval shows this value for population. Now this is from sample. You know what is the population? If you consider your population, the beta 2 value is between these two values at 95% confidence. In the same interpretation you can give for this one also. Okay, experience. The coefficient related to experience is between 0.57 and 1.3 at 95% confidence level. True value of beta 3. That means true value of beta 3 mean the coefficient related to population is between these two values at 95% confidence level. And also for the constant, you can say a value of constant is between these two values 23 and minus 6 at 95% confidence level. Now this is the way to interpret the figures in this table. I think now all these figures we discuss. If you have any doubt up to this point, you can raise.
Sir, could you please explain again the P greater than T column?
Okay. That means now these two columns help you to conduct hypothesis testing. Actually, now in the stat, we learn how to develop hypothesis. For the econometrics, actually, you don't want to write down these hypotheses, but for the understanding, we can write it. Okay, but when you are writing, you don't need to write. Okay, unless if we ask to give the detail. Okay, now let's say beta 2 is this value. Okay, then your null hypothesis is beta 2 equals 0. Your alternative hypothesis is beta 2 not equals 0. Then you will have to tell whether you are going to accept or whether you are going to reject. If you accept this, that means this value is then 0. If this value is 0, there is no any relationship between schooling and earnings. There is no any relationship between schooling and earnings. If you reject this, that means beta 2 is different from 0. That means there is a relationship between earnings and schooling. Then how to come to a conclusion whether you are going to accept or whether you are going to reject. It is very simple. You have to consider this value. This is we call p-value. If p-value is less than to the level of significance, the level of significance normally 5% that the researcher can decide. Okay, these things we discuss for the stat. If the p-value is less than level of significance, we reject this null. That means our conclusion is beta 2 value is significantly different from 0. Beta 2 value is significantly different from 0 as p value is less than the level of significance, which indicate that schooling is a significant determinant of earnings. Okay. Then actually here t value is equal to this coefficient divided by this. If you are doing manual calculation, actually now you can see the critical value. Okay, it is not given here. Then this t value is here in the rejection region. Okay, but no need to make a little confused. Then you compare this p value with the level of significance. If it is less than level of significance, you can say it is significantly different from 0. Is it clear now?
Yes, sir. Thank you.
Okay, then we discussed actually earlier this value. What is this? R square. R square. How to interpret this R square? How to interpret this R square? Yes, any answer? It is a indicator of goodness of fit. It is an indicator of goodness of fit. Then we learn R square is equal ESS, explain sum of square, divided by TSS, total sum of square. Now in this regression output, you have given TSS. This is the TS. Then this is the RSS. This is the ESS. Okay. R square is equal TSS, ESS divided by TSS. That means 87, 35 divided by this. It is equal 0.12. Okay. Then how to interpret this value? Actually, this shows the proportion of total variation. This is we call total variation. Proportion of total variation explained by the regression model. This is the total variation of Y. This is the explained variation. Then R square shows proportion of total variation explained by the regression model. That is the one interpretation. Proportion of total variation of dependent variable explained by regression model. is 0.12. Okay. Then R square value is 0.12, which indicate that only 12% of total variation of dependent variable has been explained by the regression model. Has been explained by the regression model. That is the interpretation for R square. Okay, then we will move to one practical example with the Excel. Okay, then you can see one Excel data set in chat box. Can you see the Excel data set in chat box?
Yes, sir.
Okay, then here we have three variables: quantity demand, let's say in kilogram, price in rupee, then income in rupee. Okay, these are the three variables. Now with these three variables, you can estimate a regression model. Let's say y is equal beta 1 plus beta 2 x1 plus beta 3 x2 errata. This is the model. Then with the Excel, you can run the model, data analysis, then the regression, okay, then the variable y, then the variable x, then the labels, then okay. And then you can see the regression results.
Doctor, could you show that again, please? How did you arrive at this?
Okay. Okay, then you have icon data analysis, then the regression, then you select your dependent variable, then independent variable, then you click here labels, then okay.
Okay, thank you. So you highlight both the independent variables.
Yes, yes. At once we highlight both.
Okay, thank you.
Okay, then now you can see the regression results here. Okay. Okay, then I will give for exercise for you. Then once you get these regression results, first one is you have to write down the regression equation. You have to write down the regression equation. This is our true model, but you have to estimate, you have to write down the value of beta 1 like this, the model you have to write. The second activity is you will have to interpret. Now in the you have to interpret the regression results, that means interpretation of beta 1, beta 2 and beta 3. Then the third point is you have to say about level of significance, or let's say hypothesis testing. Hypothesis testing. That means you will have to say whether these values are significant or not. Then the fourth one is confidence interval. Fourth one is confidence interval. Then the fifth one is interpretation of R square. Interpretation of interpretation of R square. Okay, then these things we discussed for the previous example. Now, as activity, based on this given information, you can write down the regression model, then the interpretation, then the hypothesis testing, confidence interval, and R square. Then here, the Y is quantity demand, it measures in kilogram. Then the X is price, it measures in rupee. Then the income is measured in rupees. Based on this information, please do this activity. Then we finish the interpretation of simple and multiple regression model. I will give maybe 10 minutes for you. Then you can write down this answer for this. If possible, you can send it into chat box, take a photo and upload, or you can type and send the answer into chat box. Shall you do this exercise? Then only you can learn this. There are 22 students. I need answer from most of you. Shall we do this exercise? Or shall I continue the discussion? It is up to you.
Let us try the example, sir.
Okay, please do it. Are you doing still?
Yes, it give like 2 minutes.
Okay, okay, sure. Okay, send your answer into chat box. Okay, then the regression equation is, you can write down 111.69 plus, so not the plus, minus 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 7.19 plus 0.01 x2. This is the regression line. Then the interpretation mean, you have to consider unit of measurement. Dependent variable we have measured in kilograms, the price in rupee, income also in rupee. Then intercept is 111, which shows that when x1 is equal 0 and x2 is equal 0, quantity demand is 111. If the price and income is 0, the quantity demand is 111. That is the interpretation for beta 1. In the beta 2, you can interpret the sign of beta 2 is negative, which indicate that there is a negative relationship between X1 and QD, price and quantity demand. Okay. And also you can say when price increase by 1 rupee, the quantity demand decrease by 7.19 kilograms. These measurements should be include price increase by 1 rupee, the quantity demand decrease by 7.19 kilogram. Or else you can say, for every change of price by 1 rupee, the quantity demand change by 7.19. Then the income, beta 3, it is 0.01. If you take actually 1 decimal places, it is 0. If you take 2, it is 0.11. So you can say the sign is positive, which indicate there is a positive relationship between quantity demand and income. When income increase, quantity demand also increase. Then this shows, the value shows when income increase by 1 rupee, quantity demand will increase by 0.01 kilograms. Okay, that is the interpretation of regression coefficient. Then significance of the coefficient, it is based on p-value. Then you can see all the p-values are less than the level of significance 5%. Level of significance 5%. And then you can say intercept is significantly different from 0 as level of significance is as p-value is less than level of significance. Then the coefficient related to price is significantly different from 0 as p-value is less than level of significance, which indicate that price is a significant determinant of quantity demand. Then the coefficient related to income is significantly different from 0 as p-value is less than the level of significance, which indicate that income is a significant determinant of quantity demand. Okay.
So now income it's 0.2.
That's what
Is it?
the last one. It's
Sorry. Yes, I made a mistake. Yes, it is 0.2, which is greater than to the level of significant 5%. Then it is not significant. That means income is not a significant determinant of quantity demand. Sorry for that. Actually, I forget it. The p-value related to income is 0.2. It is greater than the level of significant, which means the coefficient of income is not a significant variable. That means there is no significant relationship between income and quantity demand. Then confidence interval. Okay, confidence interval. Now confidence interval for income, you can see it is minus 0.1 to 0.04. Okay, that means you are 95% confidence coefficient related to income is between minus 0.1 and 0.04. In a confidence interval, if one value, mainly lower value, is minus and upper value is plus, if this is the situation, that coefficient is not significantly different from zero. Any regression output, if lower value is minus, upper value is plus, then that coefficient is not significant. Then the confidence interval related to price, you can say I am 95% confidence true value of coefficient related to price is between minus 13 and minus 1.15. Then intercept, true value of intercept of this regression model is between 56 and 167 at 95% confidence level. This is the interpretation for confidence interval. Then R square, you can see R square is equal ESS divided by TSS. This is the TSS, this is the ESS. Okay. Then if you divide this value by this, you have R square, this value. Then R square shows proportion of total variation explained by the regression model. Now here R square value is 0.89, which indicate that 89% of total variation of Y or total variation of dependent variable has been explained by the regression model. Okay. 89% of total variation of Y has been explained by the regression model. And this is the way to interpret regression results. I think in this regression output now we have few more figures we have to interpret. This F value and maybe adjusted R, then the standard errors and the multiple R. Then these things we will discuss in the next session. Then we can finish the discussion related to simple, linear and multiple regression model. Okay, this is the end of today's discussion. I think one student is recording the schedule. Who is the recording the session? Yes, he can share the recording with others. Okay. I think Rimasha. Hello.
Yes, sir.
Okay, then you can share the recording with others if others need. Okay.
Okay, sir.
Okay, then shall I wind up the session?
Thank you, sir.
Okay, bye.
Thank you, sir.